dear students, welcome back to my channel. My name is Prachi and in today's session I plan on covering a sample paper of chemistry. So if you have covered up your syllabus and your exam is pretty soon, let's say it's tomorrow, and you don't have enough time to do the entire sample paper on your own, then just tag along the video, look at what kind of questions to expect and what would be the correct answers. Another thing would be, let's say you have enough time for the exams. In that case, download the question paper from the description box and solve it on your own. Once you have covered it up, then come back on the video and as we go along, just check if your answers are correct. Another important thing is that in this session, I am not covering how you are supposed to frame the answers. We are just looking at what the answer is. There is a separate video that I will make on how to frame the answers for board exams, and if let's say you have a question for 4 marks, how you should be able to lay out the entire answer that you do not lose any mark on it. That would be a separate video. So in this particular session, we would go pretty fast because it's a big sample paper, and we would quickly see as to what answers would be the correct ones. So without any further ado, let's get started. Alright students, let's get started with the sample paper without wasting any time. So looking at the first couple of questions, alright, let's just look at the paper pattern first. So you have 2 sections in the exam. First section would be about 40 marks and your section 2 would be for 40 marks. So the total exam is for 80 marks. The time allotted for the entire exam would be 2 hours. Now, when we look at the section first, that is a compulsory section. Section 2, in that you will have about 6 questions and you are supposed to attempt 4. So you get a choice of 2 questions. Now, let's get started with the first section. So the first section says elements A, B, C and D have atomic numbers 20, 8, 6 and 17. Without identifying the elements, answer the following questions. What type of bonding is formed between A and B? Alright, so first we look at the electronic configuration of all of them. So let's begin with the first one. So you have A is 20, so 2, 8, 8, 2. Then you have B, so that would be 2, 6. Then you have C, that would be 2, 4. And then you have D, that would be 2, 8 and 7. Now let's look at the type of bond. So A and B, if you look at A and B, that is going to form ionic bond. So you can write ionic bond, and since the question is also asked to write the formula of the compound, then you will also write AB. Now moving on to C and D. So C is here, that is 2, 4 and D is 2, 8, 7. This will form a covalent bond. And the formula would be CD4 because about 4 D electrons would be shared. Then A and D. So A and D would be A is 2882, D is 287. So that will form AD2, an ionic bond. So ionic bond, you have A and D. So AD2. Now moving on to part B, that is fill in the blanks. All salts are strong electrolytes. The solution of weak electrolyte contains both ions and molecules. So ions and molecules. The solution of strong electrolyte contains ions only. The bonding present in both phosphorus trichloride and phosphorus pentachloride is dash. So you have covalent bonding in these compounds. So you have covalent bond. But phosphorus trichloride is liquid and phosphorus pentachloride is solid in state. So liquid and solid in state. Now students, if you're getting stuck in any portion or you don't understand how these answers are coming, you can drop a message in the comment section and I will be happy to help. Now let's move on to part C. Alright students, let's move on to part C. Now, write balanced chemical equations for the following equations. Now, you are supposed to balance the equation. So, remember that you lose marks if your equations are not balanced. Let's look at the first one. Iron with dilute sulfuric acid. So, the equation would be Fe plus sulfuric acid H2SO4. That will give me FeSO4 plus H2. Then sodium hydroxide with sulfur dioxide. So sodium hydroxide is what? It is NaOH plus sulfur dioxide SO2, which will give me Na2SO3 plus water. Let's look at the balancing. Add a 2 here, 2 NaOH plus SO2. Yeah, that's correct. Now moving on, we have copper oxide with dilute nitric acid. So copper oxide would be CuO plus dilute nitric acid HNO3 will give you CuNO3 whole twice plus water. Okay, let's quickly look at the balancing. Add a 2 here, 2H2, then alright, that's all. Now moving on to sodium thiosulfate and dilute hydrochloric acid. So sodium thiosulfate would be what? So that would be Na2S2O3 plus you have dilute hydrochloric acid. So HCl, that will give me NaCl plus H2O plus SO2 plus S. Now let's look at the balancing. So add a 2 here. Now for hydrogens, I will have to add a 2 here. So Na2S2O3 gives me 2 NaCl plus H2O plus SO2 plus S. Now moving on, nitrogen reacts with hydrogen. So nitrogen N2 plus hydrogen. Now this is a reversible reaction. So you have to put in the arrow. This reaction takes place in the presence of finely divided iron and you get ammonia in that. So NH3. Then you can balance it out. So the balancing would look like something 3H2 and 2 of ammonia. So that is it in the C part. So you can take a look at the equations again. If something is not making sense to you, feel free to drop a message in the comment section. Now let's look at the D part. What will you observe when gold is placed in aqua regia? So gold dissolves completely. So gold starts getting dissolved in aqua regia. Why is that? That is because of the presence of nascent chlorine. Okay, so nascent chlorine helps gold dissolve in aqua regia. So it dissolves. You're only supposed to write what you observe. So you're not supposed to give in a lot of detail as to what is happening. You can only give the observation. That means the color change, something being soluble, any particular kind of PPT formed. So that all of that information will come in your observation. Now next is sulfur dioxide is slowly passed through potassium permanganate solution. So this particular solution will decolorize. So decolorize. Then you have sulfur dioxide is passed through lime water. So lime water turns milky. Sodium hydroxide solution is slowly added to lead nitrate solution. So you will get a white PPT of lead hydroxide. So lead hydroxide white PPT is formed. This much information is sufficient, but if you would like to enhance your answer a bit more, you can mention that in excess solution this particular PPT will dissolve. That means it is soluble in excess solution. Then silver nitrate solution is mixed with sodium chloride solution. In this case also you will get a white PPT. So we'll mention that over here. So you get a white PPT of silver chloride. And this also dissolves. So and soluble in excess solution. Alright students, let's move on to the next part. Now the E part is saying that write balanced chemical equations for the observations in the first part. So all the parts that we did and we just discussed the observations of, we are supposed to give the equations for the same. Now let's look at the first one. Let me just figure out some space. So I'm going to write the equations right here. Okay. So the first one is gold is placed in aqua regia. Now what is aqua regia? It is a combination of HCl concentrated and nitric acid in the ratio of 3:1. When these two components combine, or let's say when you combine 3 parts of HCl with 1 part of HNO3, they give you nascent chlorine. So this nascent chlorine, you can imagine it to be like a free active chlorine in the solution, and since it is highly reactive, it is able to react with gold and platinum and silver. So any non-reactive metals that we know of, it is easily able to dissolve those. And this comes by the combination of 3:1 of HCl and HNO3. So let's go ahead and write the equations for it. So we'll be writing for aqua regia. So in this one you have to give both the equations. First, the equation would be HCl combining with HNO3 giving you nascent chlorine and whatever else you get. Then that nascent chlorine goes ahead and combines with gold, and then you complete the equation. So let's go ahead and write the answer here. So the part is E. So E, first part. So first part is saying aqua regia. So 3 of HCl plus 1 part of HNO3 will end up giving me NOCl plus water plus nascent chlorine. Now let me just quickly balance it out. I think I just missed water. So twice of water, and that's it. Now you have to mention that both of the acids are concentrated. Then you go ahead and use that nascent chlorine to combine with gold. So you will get Au plus 3 of nascent chlorines, which give you AuCl3, and that's it. Moving on to the second part. Now the second part is saying sulfur dioxide is slowly passed through potassium permanganate solution. So you directly have to give the equation. So sulfur dioxide, one thing is that sulfur dioxide is passed through potassium permanganate. You also have moisture in that, so don't forget to add water in the reactants. So sulfur dioxide and potassium permanganate. So SO2 plus water plus potassium permanganate would be KMNO4 will give you K2SO4 plus MnSO4 plus H2SO4. Okay, now you can balance it out. So SO2 that I'll have twice of water and then twice of KMnO4 because you have K2 here. Then on this side you will have twice of MnSO4 plus twice of H2SO4, and then 5 SO2. Let's quickly compare that if both the sides look correct. And that's it. So this is your balancing for the second part. Moving on to the third part. So the third part is sulfur dioxide is passed through lime water. So if you're getting lime water, what would happen? So you have sulfur dioxide. So SO2 with lime water. What is lime water? It is CaOH whole twice plus SO2, that would give me CaSO3 plus water, and it looks balanced. Yes. Now the fourth part would be sodium hydroxide solution is slowly added to lead nitrate solution. In this case you have to understand that it is being slowly added. That means when the first part of the reaction happens, when you have sodium hydroxide reacting with lead nitrate, you will end with lead hydroxide first, and then lead hydroxide continues ahead to combine with sodium hydroxide because it is slowly being added. So you have to give two equations. So the first equation would be PbNO3 whole twice plus NaOH, which gives you PbOH whole twice plus NaNO3, and this lead hydroxide will continue ahead to combine with sodium hydroxide. So let's do that. So you have PbOH whole twice plus NaOH, which would give me Na2 PbO2 plus water. Okay, now let's look at the balancing. Now in this question, this is for 1 mark, so you get half a mark for each equation. You miss out any one of the equations, you definitely lose half a mark. Now let's balance them out. So this will be 2 NaOH. On this side I'll have 2 NaNO3, and that looks correct. Then you have twice here Na2, sodium is balanced, and then twice of water, and that's it. This is your 4th part. Alright students, doing good. Let's move on to the 5th part. Silver nitrate solution is mixed with sodium chloride solution. So silver nitrate is AgNO3. So AgNO3 is mixed with NaCl, and that will give me AgCl as the PPT plus NaNO3. And that's it. This finishes up the D part. No, sorry, the E part for us. Now moving on to F. So F, first part says define molar volume. This is not in the syllabus this year. And if you are interested to still know, drop a comment and I will help you out. Let's move on to the next question. So you have twice of carbon monoxide that is reacting with oxygen and giving you twice of carbon dioxide. The question is asking what volume of carbon dioxide is obtained by burning 14 grams of carbon monoxide in oxygen completely at STP. Alright, now first of all, we'll look at what you have. You have carbon monoxide. So what is the value for carbon monoxide? It is 28. And you, as the equation is balanced, you have 2 in front of it. So 2 times 28. So let's start writing that first. F, second part. Alright, so you have twice of CO plus oxygen giving you CO2. So because 2 times 28 grams of carbon monoxide, that will give me 2 times 22.4 liters of carbon dioxide. Okay, now we are looking for 1 gram first. So 1 gram of carbon monoxide will give me 2 times 22.4 divided by 2 times 28 liters of carbon dioxide. Now the question is asking for how many liters? It is asking for 14 grams. Okay, so now 14 grams of carbon monoxide gives me, just multiply this by 14. So 2 times 22.4 divided by 2 times 28 times 14 liters of carbon dioxide. And once you solve this further, that gives you the final answer. Alright, let's move ahead. I know we are moving at a faster pace. This is what I'm trying to do is I'm trying to finish up the sample paper as quickly as possible, but I can definitely make a separate video in which we can go in more detail. If you would like that, please let me know. Alright, moving on to part G, that is name the following. So what is the most reactive halogen? So you can go for fluorine or chlorine. Both of them are correct answers. Then most metallic element. So most metallic element would be cesium. Then the third is radioactive element of group 2. That would be radium. Fourth is least reactive halogen. Least reactive halogen would be iodine. Then fifth part says an acidic oxide of carbon which causes greenhouse effect. That would be carbon dioxide. So CO2. One important thing to understand in this is that I am writing the formulas here, the symbols like CO2, fluorine, chlorine, F and Cl, but these are not acceptable answers in the examination. So you are supposed to give in the proper spelling of the compound that you want to answer as. So make sure that do not give in formulas, do not take any shortcuts, write the full name. In the bracket you are free to write the formula. Alright students, let's move to the last part of the first section. So this question says write balanced chemical equations for the following conversions. So this type of questions appear a lot in the exams. So you should be able to understand how you can add or subtract a compound. For example, let's say you have iron Fe, and then you are trying to convert it into ferric chloride. So ferric chloride would be FeCl3. So how you can add that up is you can add chlorine to it directly. That means iron reacted with chlorine. So I'm just gonna write up stuff here. So plus chlorine, that will give you FeCl3. Now from FeCl3 you are trying to replace chlorine and you are trying to put in hydroxide, that means OH thrice. So how would we do that? So now you can react it with NaOH, because chlorine will go with sodium and make NaCl, and the hydroxide OH will get combined with iron. So over here I can write plus NaOH. Now once you have NaOH and you end up with FeOH whole thrice, now you can decompose it. How do you decompose it? You just provide heat to the compound. When we provide heat to the compound, water gets out. So in FeOH that you have, the H will come out with extra oxygen, and whatever is left would be Fe2O3. So at this place I am just making a symbol of heat. That will give you Fe2O3. Now let's come down. Okay, this was A, B and C. Now let's come down in the flowchart. So now coming to D. Now you have FeCl2. So for FeCl2, we'll combine Fe with HCl. So add HCl here. Now you have FeCl2. Now we do the same thing. That is, you react FeCl2 with NaOH and replace the chlorine with OH. So plus NaOH. Now let me give you the equation so you have better idea about it. I won't be balancing them to save some time. You can balance them on your own. So let's look at equation number A. So equation number A is that iron is combining with chlorine Cl2, that will give me ferric chloride. Then equation B will be FeCl3 combining with NaOH, and that will give me FeOH whole thrice plus NaCl. Then equation C, now you have FeOH whole thrice. You are decomposing that by providing heat. So if you decompose that, we end up getting Fe2O3 plus water. Now moving on to equation D. Now I am coming down in the chart. So iron will react with HCl. So Fe plus HCl will give you FeCl2 plus hydrogen. Then equation E will be FeCl2 plus NaOH will give me FeOH whole twice plus NaCl. That's it. This concludes section 1. Now whenever you get a flow chart, if in the flow chart itself, try to think about it, and if you can put in these key points right there, these help you while you are making the equations and you make less mistakes. And this also saves time because you get an idea about what equation I'm trying to make. And of course at the end you need to balance, because the question says write balanced chemical equations. So if you don't balance it, you would lose marks. Now let's move on to section 2. As I have already mentioned in the beginning, section 2 you only have to attempt 4 questions out of 6. So you have a choice to leave out 2 questions. But in this session we would be covering up all the questions. So let's begin with question number 2. The following questions are related with electrorefining of impure copper. Okay, so you're refining impure copper. Name what is at the cathode, anode, what is the electrolyte. Very simple. So at cathode you have pure copper. This is first part. Then I'm just trying to save space, so I'll just write everything here. So the first part would be at cathode you will have pure copper, so pure copper. At anode you will have impure copper, so second part would be impure copper. Third part is what is your electrolyte. So you can use acidified copper sulfate solution. So the third part would be acidified copper sulfate solution. Now fourth part says that write equations taking place at cathode and anode. So I'm going to utilize the space right here. So for the fourth part, I'm going to write it at cathode first. So at cathode, I will get Cu2 plus 2 electrons, giving me copper. At anode, I'm going to get Cu minus 2 electrons, and this will give me Cu2 plus. So you get an ion. An ion is formed. Now the second part, okay, question 2 says, give equations for electrolysis of molten lead bromide at cathode and at anode. Okay, that is simple. So I'm just gonna write fourth, okay, fifth, we are on part 2. Okay, equations for lead bromide. Okay, so what will be lead bromide? So first I'll write for cathode, then I will write for anode. So for cathode, what would happen? Lead bromide. So you'll have lead. So Pb2 plus 2 electrons will give me Pb. You'll get lead. Now it says bromide. So anode, you'll have bromine, something with bromine happening. So that will give you Br minus. It's an ion. That will combine, or that will lose 2 electrons, and that will give you Br, nascent Br. Let me just balance this out. So 2 of bromine ions will lose 2 more electrons, and you will end up with 2 of bromine. Okay. Now this is nascent bromine. 2 of them, what would happen is nascent bromines is like in the solution. 2 of nascent bromines will combine together to give you bromine, Br2. So further, the equation would look like 2 of Br, that is nascent bromine, will combine and give you Br2. I hope this much makes sense, guys. That is it for question 2. That yeah, we do not need anything else. Then question B. Oh, how does HCl react with the following: sodium carbonate, sodium sulfite, and magnesium? So when you look at the question, the first thing you should recall would be the properties of HCl. So in hydrogen chloride, what have we done? If you have sodium carbonate, your output gas should be CO2. When you have sodium sulfite, your output gas should be SO2. And when HCl is reacting with any metal, for example magnesium, your output gas would be hydrogen. Okay, once you have these in place, now you can go ahead and write the equations without making any mistake. So let's see. So B, first part, you have sodium carbonate. What is sodium carbonate? It is NaCO3. So Na2CO3 plus HCl will give me NaCl plus water plus carbon dioxide. Now the second part of the same part is sodium sulfite. So sulfite is Na2SO3. So Na2SO3 plus HCl will give me NaCl plus water plus SO2. The third part is just magnesium. So HCl plus magnesium will give me MgCl2 plus hydrogen gas. Okay, I hope question 2 makes sense. Alright students, you are doing a great job so far. Let's move on to question number 3. Now this particular question is based up on analytical chemistry. If you have not done that chapter yet, and if you're facing any doubts, please check out the video that I will add the link to in the description box, and also link up somewhere here on the screen. Now, analytical chemistry is a very important chapter. You need to be aware about the kind of precipitates you get. What are the colored precipitates? Then what anions and cations are formed? Which of the solutions, for example, you get a PPT, which ones are soluble in excess solution and which of them are not. Highly important chapter. For now, we won't be going in all the details for every part of it. We will quickly look at the kind of answers you're getting. Now, if you look at question number 3, it says name the gas evolved and write the balanced chemical equation when. Now, look at the marking scheme. 4 plus 2 plus 4. This says that A part is for 4 marks. Each part is for 2 marks. So first part, ammonium dichromate is heated. If you do not know the equation and you are just able to give the name of the gas, you still get 1 mark for it. And 1 mark is for a balanced equation that you give. So if you still can get hold of the gas name by looking at the name of the compound, you still get 1 mark. So even if you are confused about a question, please give it a try with your basic knowledge of compounds, by understanding what kind of gas may come. For example, second part, you have ammoniac. Okay, so what will that give you? That will give you ammonia gas. Okay, just by looking at the question, try to give a guess. If you do not know the question, do not try to skip it completely. Okay, now let's look at the first one. Ammonium dichromate is heated. So when you have ammonium dichromate, let's look at the formula for it first. So that would be NH4 whole twice Cr2O7. Now when you are heating this, what will you get? Now the kind of gas you will get would be nitrogen. So N2, make sure you mention the name of the gas separately from the equation. So I'm just writing the equation here. So the answer in this gas would be nitrogen for this and ammonia for this. Now let's look at the equation. I will get nitrogen plus water plus chromium oxide. So Cr2O3. So Cr2O3, that will be chromium oxide. Now, so you have the ammoniac reacting with slaked lime. So that equation would be NH4Cl. What is slaked lime? That is CaOH whole twice. And that will give me CaCl2 plus water plus ammonia. So this, I do have space here. I'll write it in the straight line. So CaCl2 plus water plus ammonia. So this is your equation for the first one. Now this is entire thing for 4 marks. Now how does ammonium hydroxide help in distinguishing between lead hydroxide and zinc hydroxide? So lead hydroxide, we will say it does not dissolve. Okay, does not dissolve. Okay, then you have zinc hydroxide. It dissolves on adding ammonium hydroxide. So you will say it dissolves. This is your distinguishing. Now lead nitrate and zinc nitrate. So lead nitrate, what would happen? A white PPT appears which is insoluble in excess. So white PPT appears and insoluble in excess. So what do we mean by this? That when you keep adding the solution in it, the PPT still stays as is. It does not dissolve or it is insoluble in the solution further. Whereas when you have zinc nitrate, the PPT is white again, but it dissolves on adding more solution to it. So for the second one, that is your zinc nitrate, we will say white PPT soluble. White PPT, and I will also say soluble in excess. Although you will have to write the answers properly in the answer scripts, I am just giving you an idea about what the correct answer is expected out of you. Now let's look at the C part. These are very common questions. If you need to practice more of the C type questions, make sure you let me know in the comment section. I can do a separate video of about 10 to 15 questions of this type from analytically. Alright, let's see. So a given greenish colored solution A on reaction with barium chloride solution gives a white PPT. So you are getting a white PPT which is insoluble in all mineral acids. So you can take an example. Okay, let's say HCl. So it is insoluble in HCl. And another part of solution A on treating with ammonium hydroxide gives a dirty green PPT. So you have to try and think about a compound in which when you are reacting with barium chloride, you are getting a white PPT. When you are reacting with ammonium hydroxide, you are getting a dirty green PPT. Okay, so what will be our cation and anion? So your cation would be ferrous. Okay, So ferrous ion. So that would be Fe2 plus. And your anion will be sulfate ion. Sulfate ion, SO4 2 minus. This is your C part, that's in solution given. Yeah, that's it. Then in the second part, a blue colored solution B on reaction with ammonium hydroxide gives a bluish white PPT which dissolves in excess ammonium hydroxide to give a solution C. So whenever you have a blue colored solution B, always think about something around copper. And you are also getting a bluish white PPT. Still keep thinking around copper. Because when you have a copper PPT, you get a blue PPT, and when it dissolves in excess solution, you get a deep blue solution. So it is dissolvable also. So if you look at this question now, the question is asking name the cation in solution B. So your cation will be copper, that would be Cu2 plus. And what is the color of the solution C? Now see, I already said that you get a blue PPT. It dissolves in excess solution and gives a deep blue color of the solution, and they ask you the solution color. So that will be deep blue. Deep blue. Alright students, let's move on question number 4. Now this is based upon the chapter periodic table. That is your first chapter. Super easy and super easy questions and free marks according to me. Now let's look at the first question. How can we compare the atomicity of alkali metals and halogens? So alkali metals are monoatomic. So I'll just write here. These are monoatomic. And halogens are diatomic. So halogens are diatomic. Now in the formation of an ionic bond, so in ionic bonds, what do we have? We have metals and we have non-metals. So in the formation of an ionic bond, metal and non-metals participate with low. Now what do we have? We have low ionization energy. So ionization energy and high electron affinity. Okay, I hope you understand. Electron affinity is the ability to get an electron. So and high electron affinity. Alright, give reasons why metals are electropositive in nature. They are electropositive because they can lose electrons to attain stability. Okay, so I'll just quickly write that. Metals are electropositive in nature as metals lose electrons to attain stability. Attain stability and convert into cation. I hope that makes sense. Now, solid ionic compounds are non-electrolytes. So in solid state, what happens is ions are not free to move. So ions are not able to move around and they are held by strong electrostatic forces. So you do not have any free ions moving around. So non-electrolytes. So let's just write that. So in solid state, let me just draw a line here. I should be able to write it like this. Okay. So in solid state, I'll just write, so no free ions held by strong electrostatic force. I'm just giving you the key points. Make sure in all the answers key points are highly important. If you miss out any key points, you definitely lose marks for it. So make sure that you are able to get the key points. Now the third part is carbon tetrachloride is a non-electrolyte. So it is a non-polar covalent compound and it contains molecules only. So no ions. So how can it be an electrolyte when it does not have any free ions? So I will just write it here. So that is a non-polar covalent compound and contains molecules only. Next, question is chlorine displaces iodine from potassium iodide. That is because chlorine is more electronegative than iodine. So chlorine is more electronegative than iodine. Okay, so this question was for 2 plus 4 plus 4 marks. So you can easily see, so 2 marks were for the first portion. That was where you were comparing the atomicity of alkali and halogens. Then 2 plus 4. So next one was 4, where you had to fill in the names. Then 4 marks for the give reasons. So I always see periodic table is 3 marks. Alright, let's move on to question number 5. Alright students, you are doing a good job so far. Let's come on question number 5. So question number 5 is based upon the study of compounds. You have 4 chapters in study of compounds. So you have different questions from different portions. Now let's look at the first question. It says give reasons for the following. Iron chloride is stored in airtight bottles. The reason is that iron chloride has a tendency to absorb moisture from the atmosphere and become wet. So such compounds which have a tendency to take in moisture from the atmosphere are known as deliquescent. Then second question is common salt becomes wet during rainy season. So common salt also contains a compound called magnesium chloride, which is again deliquescent. So it has a tendency to absorb moisture. So for both of them, the basic answer is being deliquescent. So I'm going to write that for you. And for common salt, you have magnesium chloride, so MgCl2, which is deliquescent. Now, how can you prepare nitric acid and hydrochloric acid using sulfuric acid? So, you have sulfuric acid, I'll just write here. So, you have H2SO4. What can you add in H2SO4? So, you end up getting HCl and HNO3. So, for H2SO4, if you want HCl, you can add sodium chloride. You can add NaCl in H2SO4 to get HCl. Then for nitric acid, what can you add? You can add sodium nitrate. So that would be NaNO3. So name the other compounds in each use or in each case. So the two compounds for HCl, you will write sodium chloride. And for HNO3, you will write sodium nitrate. Okay. Now, the second part says write balanced chemical equations for the reactions. So, let's just write the equations up here. So, I have H2SO4 reacting with NaCl once, and then I have H2SO4 reacting with NaNO3. Now, what are we getting? Now, both of the cases, your sulfuric acid is concentrated. You have to mention that. Then with the H2SO4 and NaCl, you will get NaHSO4 plus HCl. Then NaNO3 plus H2SO4, you will get NaHSO4 again plus HNO3. So these are the reactions required for this particular question. This is question 5B, second part. Now, moving on. Okay. Write balanced chemical equation for the reaction of copper with dilute nitric acid and concentrated nitric acid. So the only difference is that when you are using dilute nitric acid, you end up getting nitric oxide as a different product. And for concentrated nitric acid, you end up getting nitrogen dioxide as a different product. Other than that, you get copper nitrate and water as the same products in both the cases. So, let me write that here somewhere. Okay, so I'll just write it here. So, I have copper with HNO3 and then copper with HNO3 again. So, when we are taking dilute, that is the first part of the question, what will you get? You will get CuNO3 whole twice plus water plus NO, that is nitric oxide. When you have copper with concentrated, so Cu plus HNO3 concentrated, you end up getting the same thing. So CuNO3 whole twice plus water, and the different thing is that you'll get nitrogen dioxide, that would be NO2. Now balancing you can do on your own. If you're not able to, I will be happy to help out. Now write balanced chemical equation for the reaction of ammonia with oxygen. The first part says in the presence of catalyst and the second part says in the absence of catalyst. Now first thing is, which catalyst do we use? We use platinum as the catalyst when we are reacting ammonia with oxygen. So what will happen in the presence of catalyst? So the first one would be that you have ammonia, that is NH3 plus oxygen, and the condition would be platinum and 800 degrees Celsius. These are the two conditions that you would have. You will get NO, again that is your nitric oxide, along with that you will get water. Now in the absence of catalyst, you will have ammonia, that is NH3 plus oxygen, no condition here. You will get N2, that is nitrogen plus water. So what you have to remember, that in the first case you are getting NO, in the second case you are getting nitrogen. And in the previous question, in the first case you had nitric oxide and in the second case you had nitrogen dioxide. Highly important. Alright students, let's move on. Question number 6. Now question number 6 is based on the chapter Metallurgy. If you understand that question and understand that chapter, this question would be super easy for you because it's not asking any big equations. Plus on the other hand, if you have not done that chapter and if you still find it difficult, please check out my channel and you have the video available on the channel. Now let's see why SO3 obtained during contact process is not directly absorbed in water. So there are two reasons for it. The first is that the reaction is exothermic, and the second is that you have a homogeneous mist of sulfuric acid created, which is very difficult to condense. Okay. Now whatever I'm telling you, I can mention them at the end in the theory, or I'll just write key points. So for example, exothermic and homogeneous mist of sulfuric acid is difficult to condense. Moving on, name the catalyst used in the contact process. So you have to understand the questions very well. Name the catalyst is the first part of the question. Write equation for the reaction taking place in the catalyst chamber. This is the second part of the question. So you have to mention the name of the catalyst separately and the equation separately. So let's see what is the catalyst used, that is vanadium pentoxide. So let's write that. Vanadium pentoxide, that would be V2O5. This is the first part of the answer. Write the equation of the reaction taking place. So that would be SO2 plus oxygen in the presence of vanadium pentoxide at 450 degrees Celsius. You will get SO3. You can balance the equation on your own. Now moving on. The following questions are related to the electrolytic reduction of alumina. The first part is, along with alumina, name the other two compounds mixed in electrolyte and why. So first is, you have to name them. So the names would be cryolite and fluorspar. Now why are they used? So the first reason is that they try to reduce the fusion temperature or the melting point of pure alumina. Why do we need to do that? Because it is very difficult to maintain a high temperature throughout an industrial process, because you are wasting a lot of external resources. So if you can maintain the temperature at a lower version and you can still get an adequate output, then nothing like it. The second reason is that cryolite acts as a solvent also. Then the third reason is that it increases the electrical conductivity of the electrolyte that we are using. So let me write all the three reasons here. So the first reason is reduce fusion temperature. The second is acts as a solvent. Then the third reason is increase electrical conductivity. Okay, now you got the three reasons. Now, why the anodes are supposed to be replaced periodically? So as the reaction is happening, our anodes get oxidized to carbon dioxide and starts getting reduced in size. So as the process keeps going on, after adequate amount of time, you need to keep replacing your anodes. So oxidized, or you can say oxidizes to carbon dioxide. Now, how does aluminium react with air on burning and with carbon? So it's very easy, very simple, small equations. So you have aluminium plus oxygen giving you Al2O3 and aluminium with carbon. So you have aluminium plus carbon giving you Al4C3. Alright, moving on to question number 7, last question of the sample paper. Calculate the percentage of metal in every compound MgCO3, Na2B4O7 and CaCl2. Very simple questions. So I'll be solving them down here in the space. So the first part says MgCO3. The second part is saying Na2B4O7 and the third part says CaCl2. What we are supposed to calculate? We are supposed to calculate the percentage of metal in every compound. So for the first part, you are supposed to get the magnesium. For the second, sodium, and for the third one, calcium. Let's start working on the first question. So for the first question, we need to find the molecular weight of magnesium carbonate first, and then we calculate the percentage of magnesium in the whole compound. So let's look at that now. All the compounds are generally mentioned down here. So you have all the values given here. So you pick up them from here directly. So MgCO3, so that will give you 24 for magnesium plus 12 plus 16 times 3, that would give you 48. So the total will become 84. Now you need to find for magnesium. So magnesium is 24 in over 84. So 24 over 84 times 100 and you get whatever the answer is. Then do the same thing for the second compound, Na2. So how much is Na? It is 23 times 2 plus 4 times 11 plus 7 times 16. So you can solve whatever you get here. So let's say you got XYZ. So then X, you are supposed to calculate for sodium. So sodium is how much? It is 24. But we need to get the molecular weight of sodium in the whole compound. So you have Na2. That means 2 atoms of sodium. So that would give me 48. Sorry, 46. 40, I didn't see that. So 46 XYZ, 46 over XYZ times 100. Simple. Then moving on to question number 3, you have calcium chloride. So that would be 40 plus chloride is 35.5 times 2. So you get 40 plus 71. So in total you get 111. Now you are supposed to calculate for calcium. So that would be how much? That would be 40 over 111 times 100. Okay students, moving to the second part of this question, very easy. So in this one they are saying NH4NO3 gives N2O plus water, and they are asking the volume of nitrous oxide formed when 40 grams of ammonium nitrate is heated. Now the first thing we need to understand is how much compound are we decomposing in the first place. So whatever amount you get, calculate for 1 gram of compound and then multiply that by 40 and calculate for 40 grams. So that would be easy to do, and then just multiply the volume of nitrous oxide with that. So let's see. So this is the B part. I'll just write it right here. So in the B part we have NH4NO3 NH4NO3 giving me N2O plus twice of water. Now let's look at the molecular weight for the compound first, and I have the values right here, so I'll just pick up the values from there. So that would be 14 plus 4 plus 14 plus 48, which would be, that would be 80. So 80 grams. Now for 80 grams of ammonium nitrate, you are getting 22.4 liters of N2O. Okay. Now how much will you get for 1 gram? That would be 22.4 divided by 80. And then how much will you get for 40 grams? That would be 22.4 divided by 80 times 40. And that whatever you get after calculating will be your answer. Now moving on to the second part. This was B part first. I'm going to do B part second on this side. So in this question they are saying, let's come back here. They are saying mass of water in grams, 154 grams of ammonium nitrate is heated. So first of all, when 80 grams of ammonium nitrate NH4NO3 is heated, it produces 2 times 18 grams of water. That is how much you have from the molecular weight. So this is how much you get. So when you are heating 1 gram, you are gonna get 2 times 18 by 80. And when you are heating, how much they asked? For 54 grams. So that would be 54 grams. So that would be 2 times 18 divided by 80 times 54. Okay. Once you solve this, whatever answer you get, that would be how much grams of water is produced. And for the previous case, we were looking at volume of ammonia. So that much liters of N2O is produced. Alright students, this is where we can conclude our session for today. We were successfully able to go through all the questions of the sample paper. Thank you so much for all your love and support. As requested, I'll be making a next video which would be based upon how to frame your answers for the examination. That means how much you are expected to write in any kind of question and how the marking scheme of the question paper works out. So if you're interested in that video, please do give me a thumbs up in the comment section and I would be soon releasing that. Thank you so much and let's catch up in the next session. Hope you have a wonderful day. Thank you.